Hello everyone, we are Zuni, Wen and Jason. Our project is real-time ray tracing. We have developed a real-time ray tracing framework. The framework is based on our assignment 3 code base, and we added Cuda parallel computing to accelerate the process of ray tracing. Thus it can render scene real-time. By real-time I mean about 20 frames per second. However, it is heavily hardware dependent. For our video, we used the i7 2600K NVIDIA GTX 570, which is a powerful desktop. We have tested on i3 GT 420. It's got 3 FPS. i7 GT 540 was about 4 FPS, and Core 2 with NVIDIA 9800 GT were about 0.3 FPS. There were 4 scenes we are going to show you. Here is the first scene. As you can see, it is basically just assignment 3 scene setup. Since we are doing Cuda ray tracing with with triangle mesh, the ray object intersect was kind of hard, so we skipped all polygons. So in the scene you will only see spheres and planes. We didn't quite figure out how area lighting as well, so we took that apart out. This is a second scene you see on the screen. It's 2 spheres with 1 mirror near the wall. So just to show you how well mirror works in ray tracing, which is pretty hard in OpenGL to achieve this. So in our ray tracer, the basic idea is to parallel every step in ray tracing. We launch 64 by 80 by 60, which is 307,000 CUDA threads in one time.
This is the third scene. We do the animation. We implement the bouncing ball. There are several balls do the bouncing. After the rays are generated, we do a parallel ray object intersects. We have to launch parallel threads for each object in the scene. Gather all the hint distance information for each object. They use the other CUDA kernel to find out the closest hit, then output the final hint information array.
This scene is actually a simulation of our solar system. All the planets are made in real ratio except for the distance. We scaled it down because distance is way too far, so we actually can't build the simulation with the real distance. And after we have hit information, then we do shading. Currently there are shading paths we have to do for each frame. Firstly, we shade the basic scene, and then we add shadow to it. Then we have to do mirror rays. After we have the color, we just copy the image back to main memory. Theoretically, we can directly map this image to OpenGL handle. Since this way we could have some memory transfer time. We have tried to do this, and there are a lot of material that talk about this. However, we couldn't figure out at the end. It has something to do with Cuda Device API, which is lower level API than what we are using. Although our code base is from assignment 3, we have to rewrite a lot of them, like ray generating function, ray object intersect function, shading function. We did both lamp and specular shading. We also had to rewrite model classes, because Cuda compiler doesn't like most of host side code. And at last, we created 3 addition scene just to demo